Now the next will come to the properties of amines. The first is your physical properties. So you will find the lower amines, that is a methylamine, dimethylamine or trimethylamine or ethylamine also. They are colorless gases at room temperature, while the higher members are liquids, we can say that. The lower amines possess a strong odor like that of ammonia, but the higher amines, alright, but the higher amines, they have got a fish-like odor, we can say that. A fishy smell it has got it. Clear? So in this way, the lower amines are gaseous, the higher amines are liquids, the lower amines are pleasant smell, not pleasant smell, the smell of ammonia, and the higher amines, they have got fish-like odor, we can say that. Now, aromatic amines in general are either they are colorless liquids or solids, and they have got a characteristic odor, the aromatic, because the name itself is says aromatic, means it has got some aroma. And the most important thing you need to remember is that they turn brown if it is a colorless. Alright, they turn brown on standing in air. Why? Because you learn it later on. It gets oxidized. Aromatic amines gets oxidized easily. So hence they turn brown on standing in air. Clear? So you need to remember this particular one. It will be used later on. Now if you see the solubilities, all the three amines, that is 1 degree, 2 degree, 3 degree amines, they are capable of forming intermolecular hydrogen bond with water. Alright, they are capable of forming intermolecular hydrogen bond with water. So hence amines, they are readily soluble in water. But if you see that amines, that is they are quite soluble in non-polar solvents such as benzene, alcohol, ether, etc. We can say that they are soluble in non-polar solvents. Alright, so in this way, amines, due to the presence of this hydrogen atoms and polar group, we can say that it is also soluble in water, and they are capable of forming intermolecular hydrogen bond with water. But if you see the solubility, then 1 degree amine is more soluble than 2 degree, than 3 degree amines. Because in 1 degree amine, you will find that is we are having RNH2, 2 hydrogen atoms is there. So it can form 2 intermolecular hydrogen bond. And in secondary we have got R2NH, 1 hydrogen atom is there. So hence it can form that is 1 intermolecular hydrogen bond, and in tertiary amines no intermolecular hydrogen bond is possible. So there the amines is being soluble due to its polar nature. Tertiary amines, it is being soluble due to its polar nature, it is being soluble, we can say that. Clear? So in this way, that is aromatic amines, they are not being soluble at all because they do not form intermolecular hydrogen bond with water due to its bulky nature. It is a bulky group, we can say that. So it forms a weak intermolecular hydrogen bond. So, and moreover, as the alkyl group increases, the number of carbon atoms in the alkyl group increases. That means the alkyl group becomes bigger and bigger. The hydrophobic character increases, the hydrophobic nature increases, and the solubility also decreases, we can say that. Clear? That you need to remember. In every cases, in organic compounds, in every cases, as the number of alkyl group will increase, alkyl group are hydrophobic in nature, the solubility is going to decrease. So for that purpose, you will find the lower, that is organic compounds having 1, 2 or 3 carbon atoms, they are much more soluble in water because the size is small, so hence it can form intermolecular hydrogen bond with water, and the polarity is also more, so to say, we can say that. Now if you see the boiling point, the amines have boiling point that is higher than those of the hydrocarbons of the comparable molecular mass, but lower than that of alcohol and carboxylic acid. Alright, lower than that of alcohol and carboxylic acid having the same, that is comparable molecular masses. The reason is that amines are less polar in nature compared to alcohol and carboxylic acid, and also it does not form what you can say the stronger intermolecular hydrogen bond, we can say that. Like in case of carboxylic acid, it forms association of molecules. Alright, in alcohols also it undergoes association of molecules due to that is what you can say, what is that, it's being, the word is being called, that is polarity, we can say that. Dipole-dipole interactions, we can say that, due to intermolecular hydrogen bonding, so to say. So, but in amines, this factor is quite, what you can say, low, this factor is. This factor is quite less, this factor is quite low, this factor is quite weaker, we can say that. This factor means polarity factor, then hydrogen bonding factor. Compared to, it's a comparable term, compared to alcohol and carboxylic acid, this factor is quite less. So hence, that is, amines have boiling point higher than those of the hydrocarbons, because hydrocarbons are non-polar. Amines are of course polar compared to hydrocarbons, but it is less polar compared to, that is, your alcohols and carboxylic acid, and also the intermolecular hydrogen bonding, the strength, if you see, is also quite less in amines. Alright, so but if you compare the boiling points, then primary amines is having higher boiling point than secondary and tertiary amines, we can say that. The reason is the same thing. In primary amines, with the presence of two hydrogen atoms, it can form association of molecules, we can say that. Clear? Stronger association of molecules, and also the polar nature is more, we can say that. So what we find is that the boiling point of primary amines is more than that of secondary amines, is more than that of tertiary amines. The primary amines have two polar NH bonds compared to one polar NH bond in secondary amines, and no what you can say NH bond is present in tertiary amines, we can say that. So hence primary amines have got higher boiling point than secondary than tertiary amines, so to say. And also I said you that primary amines is capable of forming intermolecular hydrogen bond with the presence of two NH bond. So two intermolecular hydrogen bonding is possible in case of primary amines, but in secondary amines with the presence of one NH only one intermolecular hydrogen bonding is possible, and in tertiary no chance at all, we can say that. Clear? So in this way, that is due to the stronger intermolecular hydrogen bonding, due to the stronger polar nature, alright, that is NH group, we can say primary is having higher boiling point than secondary than tertiary, we can say that. That's primary means primary amines, I mean to say. Alright, now if you see amines, they are basic in nature. They are having a basic character, that is amines. How can we say that? Due to the presence of lone pair of electrons on nitrogen atom. Due to the presence of lone pair of electrons in the nitrogen atom, we can say that. They are basic in nature, we can say that. They have got a basic character. Alright, they act as a Lewis base, so to say. Lewis base. You know, Lewis base means what? They are the electron donor group. If it will have electron, then only it is going to donate now. If it will have electrons, then only it is going to donate. So due to the presence of the electron donor group, what do you find? That amines are basic in nature. That is, in the nitrogen atom, you are having a lone pair of electrons present in it. Got it? Due to the presence of that, you can find it out that amines are basic in nature. Got it? Every amines, whether primary, secondary, tertiary amines, we can say that. But they are less basic than ammonia. Why? Because in amines we are having, let us say, primary amines, RNH2. We are having an alkyl group, which is an electron donor group. So electron donor group, what is that? What it does is that it increases the electron density on the nitrogen atom. It increases the electron density on the nitrogen atom. It increases electron density, due to which the nitrogen behaves as, what you can say, more donor, but compared to ammonia, which do not have any donor, what you can say, group present in it. So due to plus I effect, the polarity increases, the basic character increases. Got it? Whereas in ammonia, there is no electron donor group, no R group, alkyl group is there. So with the absence of the electron donor group, ammonia is less basic than amines. I hope you understood. Here due to the plus I effect, as the plus I effect is more compared to this, here no plus I effect is there. There is no alkyl group, there is no donor group. So electron density in the nitrogen atom does not increase, but the electron density increases here. Here the electron density increases. So as the electron density increases, the basic character increases. Now, how can we say this? How can we prove this particular thing? Let us react with water, because I told you amines are comparatively soluble in water. Definitely, they are readily soluble in water to a certain extent. So hence, what will happen is that here water, that is definitely you know that H plus OH minus. So this is going to give it to this particular H plus ion. Alright, it is going to give it to this H plus ion. Why? Because if I draw the structure, it will be much more easier for you to understand. Here two lone pair, so this pair of electrons is being taken away by oxygen, and hence it is positive, we can say that. Clear? So as a result, let me remove the sign then. So you can see it very clearly here. So hence this pair of electron goes here. So when this pair of electron goes, what it forms? It forms RNH3 plus and OH minus is released, we can say that. Clear? RNH3 plus and OH minus is released. Now what about here? What about here in case of ammonia? Ammonia is also highly soluble in water, no doubt about it, no doubt. 702 volumes of ammonia is soluble in 1 volume of water, highly soluble. But here it forms what? NH3, this lone pair, it comes here. So NH3 reacts with H plus to form NH4 plus and OH minus. Now this is not stable. This particular ammonium ion is not stable compared to, that is your alkyl ammonia ion, we can say that. Got it? So here what we find is that this particular one is stable compared to this, we can say that. Due to this reason, OH minus ion is readily released in case of amines than in case of ammonia. So to say. So hence, what you find is that is amines are more basic in nature because it releases OH minus ions readily, not H plus ion. OH minus, because I'm talking about the basic character. So OH minus ions readily. And moreover, if you see the Kb value, Kb means base dissociation constant. The base dissociation constant Kb value is much more in amines than in case of ammonia, so to say. Alright, the Kb value, if you see it, that is in amines, it is much more than that is we can say ammonia. So, or that is the pKb, that is if you say the smaller the value of pKb, greater is the basic strength of amines, we can say that. The smaller the value of pKb, what is pKb? Minus log Kb, already we have read it. The smaller the value of pKb, that is stronger is the basic strength of the amines, so to say. So greater the value of Kb, stronger is the base, we can say that. Greater the value of Kb, and lower the value, smaller is the value of pKb. So both I am saying you, if you get Kb value, you have to see the greater value. If you see the pKb value, you have to see the smaller value. Because pKb is minus log Kb, so automatically it becomes smaller. So the smaller the value of pKb, greater is the basic strength of the amine, we can say that. Clear? So hence the primary amines is more stronger than ammonia. For that particular reason, we can say that. Now we will see, we will compare the basic strength of the different types of amines. Will compare the basic strength of the primary, secondary, tertiary amines. Will compare it and we'll see it, what it happens. Clear? This is very important, children. Look at the board and understand it. Very important. Now, if I compare the basic strength of aliphatic amines and ammonia, I've already said you that 1 degree, 2 degree, 3 degree amines are stronger bases than ammonia. Already I said you, just now I explained you. Got it? So that you understood that they are stronger bases than ammonia. Why? Because I've already told you that the presence of plus I effect, we can say that, which is not present in ammonia. Clear? So as a result of the electron density on the nitrogen atom which increases, consequently the aliphatic amines can donate the lone pair of electrons more readily than ammonia. I've told you. Alright, it can donate the lone pair of electrons from nitrogen more readily than ammonia. This is why aliphatic amines are stronger bases than ammonia. Now if you compare the strength, the basic strength of primary, secondary and tertiary amines. Now see here. So in primary amines, that is RNH2, we are having one alkyl group. So the plus I effect is there, 1 degree amine. Alright. Now next in 2 degree amine, what you see is that is R2NH. So here 2 alkyl groups is there. So the electron density is more. Alright, in 2 degree amine. In nitrogen, the electron density is more, so the OH minus ion will be readily released compared to 1 degree amine. Because here 1 alkyl group, here 2 alkyl groups. Definitely plus I effect is more here than this, then here, we can say that. So hence what you find is that it will be more basic than this. It should be fine. Now next is R3NH. It should be still more basic, because if I do here 2 arrows, let me do here 3 arrows. Because 3 alkyl groups is there, 3 degree amine. So on the basis of plus I effect, what we find is that 3 degree amine is more basic than 2 degree amine than 1 degree amine. On the basis of plus I effect, I am saying you. Plus I effect, 3 degree amine is more basic than 2 degree than 1 degree, is clear in front of you. We can say that. Clear? Because here the OH minus ion will be readily released if I consider only the plus I effect. But I can't consider only the plus I effect. I can't. Why? Because the secondary product which will be formed, that has also to be seen. The product which will be formed, whether it will be stable or not, that also has to be seen. In this case, it is not. Why? Because 3 alkyl groups is there. I have already discussed with you. It will suffer steric hindrance. It will suffer steric repulsion. And due to repulsion, it is not stable. It is unstable. As it suffers steric hindrance or steric repulsion, so 3 degree amine is less stable in nature compared to all the amines. Compared to all the amines, it is less stable in nature. Again I repeat, here if I consider only the plus I effect, then definitely clearly it shows 3 degrees greater than 2 degrees greater than 1 degree on basicity, basic character, not basicity, on the basic character, we can say that. Clear? So, but I can't consider only the plus I effect. I have to see the other effect also. I have to see the steric effect also, the steric hindrance also. Because I have to see the product which will be formed, that will be stable or not. That also has to be seen. RNH3, R3NH plus water will give you R3NH plus OH minus. Isn't it? You will be getting it. So that has to be stable or not. That also I have to see. Because if the product is not stable, if the secondary product is not stable, then how OH minus ion will be readily released? In this case, it suffers more steric hindrance than this. So tertiary amines is least stable in nature. It's least stable because it suffers more steric hindrance due to the presence of 3 alkyl groups, bulky groups we can say that. So tertiary amines is not basic. Then which is more basic? Very clearly 2 degree is more basic than 1 degree, and as I said, tertiary amine is the least stable. So hence what you find is that 2 degree amine is more basic than 1 degree amine, which is more basic than 3 degree amine, which is more basic than ammonia. We can say that. Clear? In this way, we can say the basic character. I hope you understood. That is the basic character. But in the gaseous phase, that is a solvent effect is missing in the gas phase. Here I have said a solvent effect. Solvent means water, I said. Like I wrote the equation also. RNH2 plus HOH will give you RNH3 plus OH minus. Isn't it? The solvent effect is there. But in gas phase, the solvent effect is not there. Means when the amines are in the gaseous phase, when these amines, primary, secondary, tertiary amines in the gaseous phase, the solvent effect is missing. So in that case, as the solvent effect is missing, the basic strength is in the order of 3 degree is greater than 2 degree is greater than 1 degree. I am repeating, in the gaseous phase where the solvent effect is missing, there the 3 degree amines is more basic than 2 degree amine is more basic than 1 degree amine, so to say. We can say that. Now, next is if you compare the basic strength of aryl and aryl amines, we can say that, the basic strength. Then aryl amines, if I see, it is less basic in nature, aryl amines. They are less basic in nature compared to ammonia and alkyl amines. Why? Because in case of aryl amines, that is your aniline, we can say that, aniline. Now here, this group is not an electron donor group. Like in RNH2, this group is an electron donor. R is an electron donor, plus I. It is not an electron donor, it is minus I effect. It will rather take electrons in this way. So the electron density decreases in the nitrogen atom. Got it? Electron density decreases. So OH minus ion will not be readily released. The polarity decreases. The OH minus ion will not be readily released. And as OH minus ion will not be readily released, aniline will be less basic in nature. So aniline is always, or aryl amines are always less basic in nature compared to alkyl amines. We can say compared to ammonia, we can say that. Understood? Here this is minus I effect. As you can see the arrow. Alright, so it withdraws electrons. So the electron density on the nitrogen atom decreases, due to which the basic character decreases, because OH minus ion will not be readily released. And moreover, aryl amines are not soluble in water also. They are very less soluble in water. Got it? And moreover, that is one more factor is also there, that resonance effect is also there. Aryl amines are quite stable in nature due to resonance. They are quite stable in nature due to resonance. That is, aniline is quite stable in nature. So hence it does not lose OH minus ions readily, we can say that. Alright, so due to this reason, aryl amines or aniline is less basic in nature compared to alkyl amines, so to say. Alright, so that is in case of aryl amines, when it reacts with water, let me write the reaction, it will be easy for you to understand it. NH2 plus HOH, that is what you find is that you get a conjugate base, isn't it? Conjugate acid. NH3 plus and OH minus. This is basic, so this is a conjugate acid. So the conjugate acid is not stable. Just now what I was saying. This is quite stable. This is not stable. The conjugate acid, it is not stable in nature. The conjugate acid is. I can write it here. It is not stable in nature. It is not stable due to resonance. We can say that. Hence, due to this particular reason, what you find is that it does not lose OH minus ions readily, and hence aryl amines or aniline is less basic in nature compared to alkyl amines and ammonia, we can say that. And one thing more you have to understand here, you have to remember it here, that when an electron pumping group, electron releasing group is attached to aryl amines, alright, then basic character increases. Like suppose CH3 group is there, or C2H5 group is there, or OCH3 group is there, or OH group is there, or NH2 group is there. They are called as electron donor group. Remember it, I've read it earlier also. Electron donor group. Got it? Increases the basic character here. In acid you have read it, electron donor group decreases the acidic character. But in base, opposite, electron donor group increases the basic character. So the presence of CH3, OCH3, C2H5, NH2, OH, if this group is present with aniline, means benzene ring NH2 and second position CH3 or C2H5, or third position, that is meta position, or fourth position, and wherever it is being present, then it increases the basic character. Alright, it increases the basic character. Again I repeat, the presence of electron donor group increases the basic character. The presence of electron withdrawing group is NO2 group, CN, then halogens. Alright, in the aniline, suppose CN is there, NO2 is there, Cl is there, Br is there. In aniline, it is there in the second, third or fourth position wherever it is attached. So it decreases the basic character. The presence of electron withdrawing group will decrease the basic character, because electron withdrawing group, I am saying, it will withdraw electrons from nitrogen. So the polarity of nitrogen atom is going to decrease, due to which OH minus ion will not be readily released, and hence the basic character decreases. We can say that. So electron donor group increases the basic character, electron withdrawing group decreases the basic character. We can say that. Again I repeat, electron donor group increases the basic character, electron withdrawing group decreases the basic character. Alright, I have told you very clearly. Now the base strengthening effect of the electron releasing group, or the base weakening effect of the electron withdrawing group, just now I said, you know, the base weakening effect of the electron withdrawing group is more pronounced at para position than at meta position. Is more pronounced at para than at meta. That means when the electron donor group or withdrawing group, if it is present at para, it will be more pronounced. That means it will be either more acidic or it will be less acidic. When it is present at para then meta. That means I mean to say like here NH2 is there and CH3 is there. So it is electron donor group. Alright, it is a base, what you can say, base increasing group. Alright, the base strengthening group, electron donor base strengthening group. So this is present at para position, and the same group is present at meta position. Meta position. This is para and this is your meta. So this is more basic than this. This is more basic than this. Similarly, here it is NO2 is there, and here also NO2 is there. So NO2 is an electron withdrawing group. It's a base weakening group. So here what you find is that this is also less basic in nature than meta. So whether the group which is attached to para is base weakening group or base increasing group, it is more pronounced at para than at meta. So whether it is increasing group, whether it is decreasing group, means base increasing or base decreasing, whatever the group is present, it is more pronounced at para than meta. Then next is orthosubstituted aniline, regardless of the nature of the substituent, usually possess lesser basic strength than aniline. Whatever the group is present, orthosubstituted aniline. Alright, for example NH2 and CH3. It is always less basic, this is ortho, then aniline, due to ortho effect, so to say. Due to ortho effect, so to say, this is less basic than aniline. Alright, again I repeat, the orthosubstituted aniline, regardless of the nature of the substituent, whatever the substituent it is, whether it is base strengthening, here it is base strengthening, or base weakening like NO2CN or whatever it is. Got it? So usually possess lesser basic character. It's always be lesser basic in nature compared to what you can say aniline. So if you combine these two, then what you'll have? So what you'll find is that para is then this. Got it? Like suppose what I am doing is that, let me take here CH3 and CH3. Let me take. And if I am asking you to arrange, got it? Then which is more basic? We can say that this is more basic than this. Again, this is more basic than this. Got it? Less basic than this. No, more basic. I am saying less basic. So the more basic I got it is this, then well, you will find this, then this, you will be getting it. The first is the basic character, this is more, then this, then this, then the last you will be getting this one. If you arrange in the decreasing order of the basic character, so to say. The next is your N-alkyl substituted aryl amines are more basic than corresponding parent aryl amine. Means if an alkyl group is present with aniline. Got it? So alkyl group means this one. Here let me write, that is better. That is NHCH3. So this is more basic in nature. I mean to say that. This is what I mean to say. This is more basic in nature. That is aryl alkyl amines. We can say that. This is clear. So it is more basic in nature compared to this. Why? Why it is? Because of the presence of electron donor group. Here the NH2 group is not directly attached to the benzene ring. Here the NH2 group is not directly attached to the benzene ring. Alright, so that what I am saying is that, sorry, I have to write it in this way. Sorry, I am very sorry. CH2 NH2. Sorry. In this way I should write, that is CH2, 2 bonds. Yes, correct. CH2, that is NH2. So this is more basic than this, I mean to say is. Because here the NH2 group is directly attached to the benzene ring. Here the NH2 group is not directly attached to the benzene ring. Alright, so hence for that particular purpose, this is because alkyl groups are electron releasing group and increases the electron density at the nitrogen atom through plus I effect. Electron donor increases electron density. This is increases electron density at the nitrogen atom. But here it is what you can say withdraw. It will take, we can say that. Similarly, if you compare the basic strength of aryl alkyl amines and aryl amines, as I said, this you got it. Now, if you compare the basic strength of aryl alkyl amines and alkyl amines, no doubt, alkyl amines is always basic than aryl alkyl amines. No doubt about it. Means if you take here C2H5NH2 and C6H5 C2H5NH2. Alright, suppose if I take here C2H5NH2. So no doubt this will be more basic in nature. This is more basic in nature, alkyl amines. Then we can say that aryl alkyl amines, so to say, this will be more basic in nature. Why? Very clearly.